All right, hey crew. We are going to do some, this is chapter 7, homework problems. Let me go shut my door though. Problems. And these are just some problems that people tend to have more trouble with. And so therefore I'm going to do them. All right, so the first one is relatively straightforward. It says, it gives you a reaction. It says, what is the mass of HBr you would need to dissolve this? The first thing we do anytime we see grams is we turn it into mole, right? So this is grams of pure iron. What that means is it's only made up of iron. So step number 1, let's take that grams and let's turn it into mole. You know that it's just iron, so you can look over here, it's 55.845. Or you could put 55.85 if you want 2 gram per mole. And let's calculate it. I did a horrible job preparing for this. Okay. Ooh, this is not the calculator I want to do. Whew. Second longer and I would have had to edit that video. Okay, here we go. Ready? So 2.6 divided by 55.85 gives me an answer of 0.404655 mole of iron. All right, we also know that this would have had 2 sig figs, so we keep 2, but we always keep 2 extras, right? So essentially up here, this is 0.04655. We only ever write mole up here. And now it wants to know what mass in grams of HBr. In other words, this is our question mark right there. Okay, so we know what to do. We can just start with what we got. That many mole. And we know that, and that was, sorry, I did a very bad job. I should have written iron. Because we know once we've written this, we know if this is a mole of iron, we have to put mole of iron down here. We know there's 1 mole of iron for every 2 mole of HBr. But we are not done. The reason I continued is because it asked for it in grams, so we can actually keep going. You could have calculated mole and then multiplied it to get the grams, but let's just do it in one fell swoop here. I'm going to take my number that I already had in my calculator, divide it by 1 times 2. And I get 0.1862. And again, that would give us the mole of HBr, but it asked for us in grams. So in class, I would always give you the molar mass, right? But in this case, I did not, so because it's your homework. So bromine is 79.904 and hydrogen's 1.008. So 79.904 plus 1.008 gives me an answer of 80.912. So that's the molar mass grams per mole. Okay, so now we're in Moletown of HBr. We know a mole of HBr has a mass of 80.912 grams. So all we do is calculate everything. So 0.04655 times 2 times 80.912, and I get an answer of 7.5 grams. This only had 2 sig figs in it of HBr. So if you want to dissolve a padlock, you need to go to the store and get yourself 7.5 grams of this very strong acid. Good luck finding it at the store. There you go. All right, so I think there's another question that asks a similar thing. It's like, hey, how much of H2 would you need? So you would do the same thing. You just move the question mark over here and use the mass of H2. All right, question number 2 says, magnesium oxide can be made by heating magnesium metal in the presence of oxygen. It's really cool. Actually burns really, really bright. It's like bright in the sun, and it can actually burn your eyes if you stare at it too long. The balanced equation for the reaction is this. When 10 grams of magnesium is allowed to react with 10.4 grams of this, 11.9 grams of magnesium oxide is formed. So step number 1, you know what I'm going to do. I'm going to take all these and turn them into mole. Okay. I'm going to do that by dividing the first one, 10.2, by magnesium's molar mass, 24.305. So all I do is say 10.2 divided by 24.305, and I get an answer of 0.4197. And that would have, let's do 6, 7, because it will have 3 sig figs, so we want to have 2 extras. And that's mole of magnesium. Now we do the same thing with O2. We divide it by its molar mass, which is 32.00 grams per mole. So 10.4 divided by 32. And I get an answer of 0.325. And I do the same thing for MgO. 11.9 divided by, and then I'm going to start a parenthesis because I know magnesium is 24.305 plus each oxygen is 16. 305 plus 16 in parentheses. And I get an answer of 0.2952 and then 5 because it's got 3 sig figs. So this one had 3 sig figs that happened to be perfect, and this one had 3 sig figs as well. Okay, so now we're starting with moles, and now we can go back and read the question. Okay, it says we're going to make magnesium oxide. It gives you the amount of this and amount of this, and it tells you that this much is collected. All right, anytime something is collected, is produced, is created, is precipitated, is filtered, is anything that happened, is produced, is yielded, those are all clues that this is the actual yield. So chances are, if you're given 2 things that are reacting, or more things that are reacting, and then an amount of something on the produce side, one of the products, then that tells you that it's probably going to be a percent yield question. And sure enough, it is down here. So do you remember that percent yield equals actual yield divided by theoretical yield times 100%, right? This is a big hint. This gave us our actual yield. It's 0.29525 mole of MgO with 3 sig figs. So we have our actual yield. Now all we need to do is find our theoretical yield and multiply it by 100%, and we'll have our answer for this part. So, all right, cool. We have used this number now. We no longer need it. Now we go back here. For the mole of magnesium, again, this is 0.41967, and the oxygen was 0.325, and we simply ask which one's smaller. If I divide this by 1, I get 0.3, but if I divide this by the 2 right here, so remember, you want to divide this by 1, divide that by 2, and ask which one's smaller. This one comes out to be smaller. This gives me a 0.2. I get rid of these numbers. I don't need them. So this is my limiting reactant, the magnesium. So when I start my problem for theoretical yield, it's always your limiting reactant up here. And that's mole of Mg. Once I've written mole of Mg, I've set myself up. If this is mole of Mg, I have to put mole of Mg here. I use the coefficient here of 2. And what am I interested in turning it into? Great question. We were given this as our actual yield, which means our theoretical yield is going to match. It's got to be the MgO. So for every 2 mole of magnesium, I get 2 mole of MgO. 0.41967 mole of MgO. All right, so that was mole. It did ask us to put it into grams, so you can just continue on. You know, a mole of MgO has a mass 24.305 plus 16 has a mass of 40.305. So I multiply it times the 0.41967. I get 16.9 with 3 sig figs grams of Mg. Okay. Now I did a bad job here. It asked about the limiting reactant. We already know what the limiting reactant is. The one that we ran out of first, it was that magnesium. All right. All right, so hopefully that helped, and now we can move on to the bottom part of the percent yield. So we now have a theoretical yield. It was 0.41967. Why am I choosing mole instead of the grams? Because this is mole, therefore this must also be mole of MgO. So 0.29525 divided by 0.41967 times 100% gives me 70.4% yield, and I know I kept all the sig figs all the way through, so that should be a valid answer. All right, moving on to the last question. All right, it says advanced, but it's really not. Let's talk about why. It's mainly advanced because it's got 4 sig figs, which is just kind of a pain in the butt, but nevertheless, it's not really that bad. So let me pull up some paper here. Let's talk about it briefly. Okay, so I'm going to go all the way back to mixing stuff. So on day 1, when we started talking about yield, I told you that it takes 2 red paints plus 3 yellow paints, and I mix them together and I get an orange, right? And then I was like, okay, let's say you go to the store and you buy 8 reds cans, 8 red cans, and then yellow also on sale, and you get 4. Let's say you get 12. Let's give you more. Let's give you 16. Okay, so you get 8 reds and 16 yellow, and I ask you how many oranges you can theoretically make. All right, so you're like, okay, no problem. For every 2 red, I need 3 yellow, and I can make an orange. 2 red, 3 yellow, I can make another orange. 2 red, 3 yellow, you can make another orange. And finally 2 red, 3 yellow, and I can make another orange. So you could make 4 oranges, right? And we called this the limiting. And this one where we have leftover is called the excess. Hopefully that makes sense, because we have leftover yellow, but we can't do anything with that yellow, right? We can't use any more, we can't make any more orange because we ran out of red. Now, just to kind of remind you what these definitions mean. This is the limiting, and this one is the excess. We got 4 oranges, that's great. But if I asked you how much excess is left, you would essentially say, well, I know that we started with 16, right? And you had to use 12, so you have 4 left. Okay, so essentially you took what we start with minus what you used, gives you what we call the excess. We're about to use this exact same idea in this problem right here. Okay. So let's go ahead and do it. First, we have lots of changing grams into mole, and we can do that. So this first one has a molar mass. If you take phosphorus and multiply it by 4 times, has a mass of 123.90 grams per mole. And you end up with an answer of 0.364407. Let's do it again just to make sure. So we got 45.15. Oops. And we're going to divide it by 123.9. And I get an answer of 0.364407. And this sucker would have, I don't know if I said 3, it has 4 sig figs. That's, remember when I said it was a pain? That's the pain. And then we have 131.7, and we're dividing it by 70.9 is the mass of Cl2. And that gives me an answer of 16. That's not right. Let me do it again. 131.7 divided by 70.9. Gives me an answer of that makes more sense. 1.8575546. This would have 4 sig figs. Cool. Whoa. So I accidentally kept 3 here. It doesn't matter, as long as you keep at least 2. Okay. It says once the reaction has occurred as completely as possible, what mass of excess remains? So in this reaction, it occurred as completely as possible. Everything that could be used up was used up. So all of the limiting reactant was used up. So we could figure out if we used up 8, then therefore we would have needed 12 yellows to react. So let's go ahead and use stoichiometry to kind of put this together. I'm going to write P4. I'm going to rewrite this so we have a little more space. So again, we're starting with 0.364407. 4 sig figs, and over here it's 1.85755. I'll switch to just that. Mole of that. And we're going to react these as much as possible, okay? So step number 1 will be, as always, find your limiting. Okay. So we divide this one by 1 and divide this by 6. This divided by 1 would be 0.36. This divided by 6, remember divided by 1, divided by 6. I write them small because we don't use them. When I divide this by 6, I can already see I'm going to get like a 0.3, and this one's going to be smaller. But let's just check. Yeah, 0.309, and this is 0.306. This is the 0.36. This one's smaller. This is our LR. Once we have that, we get rid of this. Okay. All right. So normally we put our question mark over here because we're looking for theoretical yield, but we don't need that. We already know, if you remember, how much we started with. All we have to figure out is how much we used up. And then we can subtract them to get what's left, just like we did with the red and the yellow, okay? So figure out how much we started with, we got that. Let's just figure out how much we used up of it, and then we can figure out what's left. There should be nothing left of the limiting reactant, because that gets all used up. That was like the red paint, it gets all used up. So that means this one, by the way, is the excess. I probably should have labeled it that. Okay, so let's figure out how much we used up. To do that, our question mark actually becomes there. So we know that we're starting with, we're going to start with 8.5755 of the Cl2. We know for every 6 mole of Cl2, we get 1 mole of the P4. So let's see how much P4 we had to use in order to react all of that limiting reactant. Zero 0.30959. Okay, 0.30959 is how much we would have to use up of this in order to get that. Again, that's mole of P4. To begin. So all you do is subtract them, this minus this. So I'm gonna get a negative. I'm just gonna keep the number of my calculator. And I get an answer of 0.0548153. Okay, that one had 4 sig figs. This actually should have had 4 sig figs. And then it happens to be 4 decimals minus 4 decimals, which would give you 4 decimals. So we have left that many mole of P4, 0.0548 mole. Now what we have to do is it asked it in grams. Why it asked it to 4 sig figs, I don't know. Somebody somewhere along the way missed the fact that you subtracted and you ended up with just a 3 decimal answer. But okay, or a 3 sig fig answer. Let's go ahead and do 4 for them. So 0.05481 mole of P4. And you know that a mole of P4 has a mass of 123.90 grams. So I multiplied times 123.9, and I get 6.792 grams of P4. All right, so hopefully that helped and made some sense. And if it didn't, watch it again. And if it still didn't, well, you know how to get a hold of me. So have a great day, y'all. Bye.